Alright, doctor. My name is Muhammad Amirul Haikal bin Muhammad Razani.
Assalamualaikum. My name is Muhammad Daniel bin Khairuzi.
Assalamualaikum warahmatullahi wabarakatuh. My name Muhammad Iqmal Habib Alias.
Assalamualaikum. My name is Muhammad Khairul Hakimi bin Muhammad Khir.
I will explain about the introduction of our mini project. The brain is a multifaceted organ that controls our body through memory, emotion, touch, motor skills, and every other process. Magnetic resonance imaging (MRI) is commonly used to diagnose brain tumors. A brain tumor is an uncontrollable growth of cancer cells that is unchecked by the checkpoint that normally controls cells growth. It is basically of two type stage of the tumor, which are non-cancerous or benign, has a uniform structure and lacks active cancer cells. It is considered a low-grade tumor. That tumors stop growing after a certain size and become encapsulated in a connective tissue health. Malignant have a non-uniform structure, heterogeneous, and contain active cancer cells. It is considered a high-grade tumor. Malignant tumors, also known as neoplasm, grow rapidly, have an infinite lifespan, and become increasingly invasive. In medical imaging modalities, segmentation is used to detect diseased tumor tissues. The act of dividing an image into specific segments or units that have common and similar attributes such as color, texture, contrast, brightness, and gray level is referred to as segmentation. To improve the image quality, extract information from the accurate image. This image processing technique is widely used. MATLAB is fast algorithm that can detect tumor from MRI image in a very short period.
So I will present about methodology for our project. The purpose methodology is applied to a real dataset including brain MRI image and was converted into grayscale before further processing. For brain tumor segmentation, an MRI of the brain is processed by using MATLAB algorithm. So this is a flow chart. We start, then we input MRI brain image, we test the brain image, then we continue to pre-processing, filtering, image enhancement, and we go to post-processing. That will be double thresholding and morphological operation and addition and term or detection, and we will end it. For pre-processing, the primary task of pre-processing is to remove noise and improve image quality, while morphological operations are performed using MATLAB algorithm to detect tumors in the brain. The pre-processing process performs the following function. The first one is filtering. For filtering, this is a method for removing image noise. Because the mean values produced by average filter blur the image, the median filter, which produces median values of the pixel, is used. The second one is image enhancement. Image enhancement is the process of modifying the digital image to make them more suitable for display or further analysis. It can, for example, remove noise and sharpen the brighten an image, making it easier to identify key features. Then we will go to post-processing. For post-processing, image thresholding is a simple but effective method of separating foreground and background areas in an image. This is a type of image segmentation technique in which objects are isolated by converting grayscale image to binary image. Morphological operators include erosion and dilation. After the image has been converted to binary format, morphological operations such as erosion and dilation methods are applied to it. The morphological operation goals is to separate the tumor from the image. The image now is only shows the tumor segment. The function of the post-processing process is the following. The first one is thresholding. Texturing is the most adaptable and straightforward method for obtaining binary image. The second one is morphological operation. Morphological operations are used to extract the boundary area of brain image. Only binary image can be processed with it. The two most fundamental morphological operations are dilation and erosion. The tumor obtained has no distinct edges or boundaries, but it has been sharpened in the image. The third one is addition. It is possible to superimpose one image on top of another by using additional technique on image. Image addition could also be used to control an image brightness. Each resulting pixel is the sum of the pixels from the two images of the same size and class. Then we go to usage of data. For this project, there are 4 different modalities of brain MRI in testing datasets, where a modality contains different information. The training datasets contain 15 brain MRI image from FLAIR, T1, T1CE, and T2. The type of image used for training datasets is a JPEG file, JPG. So we can see image slice 110 for FLAIR, image slice 110 for T1, image slice 110 for T1CE, and image slice 110 for T2.
And for my part, I will explain about the result. And for the result, the research was carried out to detect and extract tumor from MRI image, and because of manual is hard, so we employ an automated segmentation technique that yield a proportionate result. So as a result, we detect identical by combining the threshold segmentation and image filtering, and also morphological process. So this method produces an excellent segmentation result by reducing the error, precision, and computational speed of segmentation methodologies, while also shortening the operation time. So we have a first pre-processing of brain MRI image, second post-processing of brain MRI image, and the lastly is final output segmentation image. And for the pre-processing of brain MRI image, this is a graphical image that has been filtered and converted into gray using MATLAB algorithm, and all noise will be removed to perform double threshold and morphological operation. And we have a 4 image. We name image slash 1110, 110, and filter image 1, flare filter image 2, T1 filter image 3, dice filter image 4, T2. And for the post processing of the MRI image, after step A, we go to step B. We applying a double thresholding followed by morphological operation. And this is a Tumor alone image slash 110 flare and T1 test and T2. And the lastly is final output. For the final output, we combine a flare, T1 test and T2 image. After the post-processing method is done, the output will appear and we add all the image, flare, T1 test and T2. And this is a result for the final. So the final, we can see the brain tumor.
And I'll be presenting the coding part for our project. The first one is the input for each of the image that we have. We just code to input the image. The first one is flare, second one is T1, and then TICE, and then T2. So that's basically for the input coding. The second one is the filtering image. To basically what filter image is we just want to remove all noises from our image. The first part of the coding is that it will display an output in which it's either pre-processing image, so that one in case the processing take time, so it will says please wait, and then after it is done, your display removing noise filtering completed. And then for each of the image, it will be display for filter image from the four image that we have. To come up filter image 1, down the font size, and then filter image 2, and so on. And that's the processing. That is for the coding for our filtered image. The third one will be the coding for the thresholding of the image, which is how we set the size for image, each one of them. As you can see, that is all for each 4 of our images. It is the first one, second one as mentioned before, and it's all for the thresholding the image. Next one will be the morphological operation. For this is basically we will display if our system detect the tumor for each of the image. For example, if the tumor is detected, it will display tumor alone, and if it doesn't, it will display no tumor. That is for the status for each of our image. Yes, and this is how we set for each image. So if they detect it, they will come out there is a tumor, and if there is no tumor, they will come out no tumor. Last one would be the final output for our system. It will display everything according to each of the image that we have. That will be the display of the status for the image, which is they have tumor or no tumor, and of course the title for each of the image, which is based on their original name.
Lastly is conclusion. MRI image segmentation is a significant yet fundamentally challenging problem in medical image processing. In most circumstances, it cannot be resolved using straightforward conventional image processing techniques. The characteristic of MRI picture make it challenging to design automated algorithms because of the partial volume effect, inherent noise, and a wide variety of imaging parameters that affect tissue intensities. There is a considerable interpretation variation in signal intensities of the same tissue type. We propose an effective classification scheme based on the density-based clustering technique to identify tumor or brain cancers. In this study, we provide a few techniques that allow for the detection or clear visualization of tumors. In addition to reducing processing time, the strategy we adopted also increased segmentation approach, precision, accuracy, and computing speed. For acknowledgement, without Dr. Rashida Hamzah, our lecturer, we will not be able to complete this report or the project we are working on. Right from the beginning of the project, she taught us a lot. We use the details she gives us to make this idea a reality. Thank you as well to the members of our project team who gave their all from start to finish to make sure the project was successful.